Chapter 4, Loops Part 1. Our goals for this chapter are to learn how to implement a while loop, a for loop, and a do loop. We're going to hand trace the execution of a program, become familiar with common loop algorithms, understand nested loops, implement programs that read and process data sets, and use computers for simulations. The while loop is an example of a pre-test loop. It is controlled by some loop control condition, and it loops a specified number of times. So for example, if we want to calculate compound interest, the algorithm was in chapter 1 of our textbook, and we want to stop when the balance is 20,000. So we start with 10,000. In year 0, we haven't yet figured out the interest, as you can see in our example there, but how do we figure out the interest? The interest is 0.05, so 5%, times the balance. So our interest for the first year is going to be 10,000. There's no interest in year 0 because that's just our starting place. So our interest in year 1 is going to be 10,000 times 0.05. Let's see if we can see this on the next screen. Sorry, we'll get back to it shortly. But this is what the flow chart would look like. Is as long as balance is less than target. As long as that is true, we increment the year and we add interest to the balance. And then we go back up and we check. Is balance still less than target? If it is, we enter the loop, we follow the true path, we increment year, we add interest to balance, and go back up and check the new balance. Isn't balance less than target? And so on. When that condition becomes false, when balance is no longer less than target, then our loop ends. And the code is shown in the gray box. While balance less than target. Year plus plus, so that adds 1 to year. Double interest equals balance times rate divided by 100. Balance equals balance plus interest. So we increase the balance by however much the calculated interest is in that particular year. So here's the syntax of the while loop. It's while is the key word, followed by a pair of parentheses, and inside the parentheses, some loop control condition, some Boolean expression that's going to control whether or not we keep looping. Note, there is no semicolon at the end of that line. While balance less than target, there is not a semicolon at the end. The while loop will execute the next statement that follows, so one statement that follows. But if we want to do more than one thing, as we do in the case of our interest problem, we need to put braces. So the braces will surround the code block that we want to execute as a result of the while. Notice also that the code is indented between the open and the close brace. This does not affect the running of the program, but it certainly enhances the readability. And it's something that you are evaluated on in every programming rubric. One more thing before we go to the next slide. Notice that we have initialized the loop control condition before we ever get to the loop. So balance is set to some value before, and so is target, is set to some value before we ever get to the expression while balance less than target. So here's how it works. Number 1, we check the loop control condition. If balance is less than target, if the condition is true, we enter the loop, we add 1 to year, as you can see in number 2 there, year becomes 1. We calculate the interest, which is 500, and we add that to the balance. So now the balance is 10,500. We go back up and check the loop control condition again. 10,500 is still less than target, which is 20,000. So we would enter the loop and add 1 to year and calculate the interest and add the interest to the balance, and so on. So after 15 iterations, we find that the balance is 20,789.28, and the year equals 15. So after 15 years, our balance is going to hit the target. The condition is no longer true, balance is no longer less than target, and we are done executing that loop. The execution would follow the closing brace. It would go on to whatever follows the closing brace of that loop. In this case, system.out.println year. Here is an example of that code, and I strongly encourage you to hit the pause button, type up this code in NetBeans, and get it working. One thing that's missing up at the top is the package statement. In NetBeans, we need to leave that package statement where it is Everything else you can change as long as you name your class double investment, but you could name your file anything you want. It's just to be consistent with what's on line 4. You would call it double investment. The reason that I think it's important to hit the pause button and try to run the code is because you might make a typo when you're entering it. You might make a mistake, and then you would learn better about how that code functions. Here are some examples of while loops. In the first example, we initialize I to 0, we initialize sum to 0, and as long as sum is less than 10, starts off at 0, 0 is less than 10, we enter the loop and we add 1 to I. We increment sum, we say sum equals sum plus I, so sum goes up by however much I is. And then we print I and sum. This is kind of a combination of Java and pseudocode. If we follow this algorithm, we will see that it will output, if we print I and sum, it would output 1, 1, 2, 3, 3, 6, 4, 10. When we get to I equals 4, sum becomes 10, and that no longer, the Boolean expression is no longer true. Sum is no longer less than 10. Take a look at the rest of the examples, and you can even try to implement some of these should you choose. Notice that on the second example, sum never reaches 10 because we're subtracting. Inside the loop we say I plus plus, and then we say sum equals sum minus I. So it will always be less than 10, and we have an infinite loop. An infinite loop is a loop that never ends. We try to avoid writing those. Rarely is there an example of an infinite loop that's what we want, so try to avoid that. In the other case, in the last example here, where we have sum I equals 0, sum equals 0, while sum is less than 0. Well, that expression is false the first time we encounter that expression, so the loop is never run at all and no output is produced. In this next case, we initialize I to 0 and sum to 0, while sum is greater than or equal to 10. 0 is not greater than or equal to 10, so again, this loop is never run at all and no output is produced. Finally, I equals 0, sum equals 0, while sum is less than 10, semicolon. Note the semicolon at the end, while sum is less than 10, semicolon. That is syntactically correct, meaning that you won't get a syntax error as a result of that. However, it's not what we want because it prevents the loop body from being executed. So do not put a semicolon at the end of the while statement.